As humans, we learn to integrate spatial awareness from infancy for efficient and agile movement. This led us to question whether it would be possible to create adaptive robots that learn and modify their behavior using only cameras looking at the ground. Drawing inspiration from innate human ability, we harness the power of visual perception to endow robots with a similar level of spatial awareness and adaptability. We present Egocentric Visual Self-Model. With this model, the robot gains the following abilities. Firstly, basic locomotion. Our robot can leverage the trained model to predict future states and perform basic locomotion tasks using only vision as observation. Secondly, robustness and adaptability. The model exhibited robustness to unseen terrains and visual disturbances. Thirdly, generalizability. The pre-trained visual encoder could be used to efficiently train self-models for new robots with different morphologies and complexities, demonstrating the potential for transfer learning in the model's applicability to diverse robotic systems. Finally, anomaly detection and recovery. The robot can autonomously detect hardware anomalies and adapt its self-model to accommodate changes, showcasing the model's potential for damage recovery.